The derivative of tangent inverse of anything is 1 over 1 plus the same thing squared, where the inner function is x squared, which is not x, so we will still need to multiply the derivative of the inside function using the chain rule, which is 2x. And then we simplify this, 2x over 1 plus x to the fourth. And that's it. Differentiate y equals sine inverse of tangent of x. This is the composite of function with the outside function being arcsine, so we will need to use the chain rule. But first, the derivative of arcsine or sine inverse is 1 over the square root of 1 minus the inside function squared. The inside function is tangent of x, which is not x, so we will still need to multiply the derivative of the inside function. The derivative of tangent of x is secant squared of x. And then we simplify this. The numerator is secant squared of x, and the denominator is the square root of 1 minus tangent of x. The quantity squared is tangent squared of x. The derivative of arctangent of the square root of 1 minus x over 1 plus x. This is the composite of function with the outside function being arctangent, so we will need to use the chain rule. First, the outside function is tangent inverse or arctangent, so the derivative is 1 over 1 plus the inside function squared, where the inside function is the square root of 1 minus x over 1 plus x. Since this is not x, so we will still need to multiply the derivative of the inside function. The derivative of the square root is 1 over 2. Whatever inside the square root, we rewrite it, and that is 1 minus x over 1 plus x. And then, since that is the inside function, we will still need to multiply the derivative of the inside function, which is now the quotient, so we would need to use the quotient rule. The denominator is 1 plus x, so we will square it. We take the derivative in the numerator. The derivative of 1 minus x is 0 minus 1, multiply the denominator 1 plus x minus, and then we keep the numerator 1 minus x, and we multiply the derivative of the denominator, which is 1 only, because in the denominator, the derivative of 1 is 0, and the derivative of x is 1. We will need to simplify this. The numerator is negative 1 minus x, because we distribute the negative 1, and then minus 1 plus x, because we distribute the negative sign, over 1 plus the radical squared is now 1 minus x over 1 plus x. The square root and the square canceled out. We will need to put this inside the parentheses because this is being multiplied to some other factors, times 2 times the square root of 1 minus x over 1 plus x times 1 plus x, the whole quantity squared. In the numerator, the negative x and the x canceled out, leaving us with a negative 2. And that negative 2 will cancel out the factor of 2 in the denominator, but we will write it out just in case. Inside the first parenthesis, the common denominator is 1 plus x, so we will take 1 times 1 plus x plus 1 minus x, and the denominator is 1 plus x, times 2, the square root of 1 minus x over the square root of 1 plus x, and then a factor of 1 plus x squared in the denominator. The 2 and the 2 canceled out. Negative 2 over 2 is negative 1. And so this is negative 1 over 1 plus x plus 1 minus x is now 1 plus 1 is 2. X minus x is gone. So 2 over 1 plus x. And then we have the square root of 1 minus x over the square root of 1 plus x. And we have a 1 plus x, the quantity squared. This 1 plus x squared canceled out the factor 1 plus x. So that squared is gone. Thus, we end up with negative 1 over 2 the square root of 1 minus x over the square root of 1 plus x times 1 plus x. At this point, we can't leave the answer in terms of complex fraction, so we would take this denominator and multiply the reciprocal, and so we end up with negative 1 times the square root of 1 plus x over 2 1 plus x times the square root of 1 minus x. There's no need to write the negative 1 in the numerator, and so this is negative the square root of 1 plus x over 2 times 1 plus x, the square root of 1 minus x. Now, this square root of 1 plus x and the 1 plus x in the denominator, we can do something about it. This is negative the square root of 1 plus x over 2. 1 plus x is the square root of 1 plus x squared. And then we still have the square root of 1 minus x. We do this because we want to cancel out the square root of 1 plus x. And so this is negative 1 over 2 the square root of 1 plus x times the square root of 1 minus x. And since the denominator is the product of the conjugate, we rewrite this at negative 1 over 2. We combine the radical. Inside, we end up with 1 minus x squared. And this is in its simplest form.